Welcome to Egler Insights, where we dive deep into the world of computer networking. Join us as we explore the latest trends, share expert insights, and unravel the complexities of networking in the digital age. I'm your host Olympio Moshi, and let's embark on this journey of connectivity, innovation, and all things IT. So in today's episode, we are going to be talking about understanding IP addresses and subnetting. Understanding IP addresses and subnetting is fundamental to networking. So let's go ahead and talk about IP addresses. And under IP addresses, we are going to be talking about IPv4 and IPv6. IPv4 uses a 32-bit address scheme, allowing for a total of 2^32 addresses. It is written in the form of 4 decimal numbers separated by periods. An example of an IPv4 address is 192.168.1.1. IPv6 uses a 128-bit address scheme, allowing for a virtually unlimited number of addresses. It is written in hexadecimal format separated by colons. An example of an IPv6 address is 2001:0DB8:000:000:000:8A2E:00370:7334. Next, we are going to be talking about classes of IPv4 addresses. There are 5 classes of IPv4 addresses, and they include Class A, whose IP addresses range from 0.0.0.0 to 127.255.255.255. Next, we have Class B, whose IP addresses range from 128.0.0.0 to 191.255.255.255. Next, we have Class C, whose IP addresses range from 192.0.0.0 to 223.255.255.255. Next, we have Class D, whose IP addresses range from 224.0.0.0 to 239.255.255.255. Class D IP addresses are reserved for multicast addressing. Lastly, we have Class E, whose IP addresses range from 240.0.0.0 to 255.255.255.255. Class E IP addresses are reserved for experiments. Moving on, we are going to be talking about private and public IP addresses. Private IP addresses are used within a private network and are not directly accessible from the internet. Their ranges include, for Class A, their range is from 10.0.0.0 to 10.255.255.255. For Class B, their range is from 172.16.0.0 to 172.31.255.255. For Class C, their range is from 192.168.0.0 to 192.168.255.255. Public IP addresses are routable on the internet and unique across the globe. Next, we are going to be talking about subnetting. So what is subnetting? Subnetting is the process of dividing a large network into smaller subnetworks or subnets to improve performance, security, and efficiency. We will also be talking about a subnet mask. A subnet mask determines the network and host portions of an IP address. It is a 32-bit number represented similarly to an IP address. Common subnet masks are 255.0.0.0 for /8 networks, 255.255.0.0 for /16 networks, and 255.255.255.0 for /24 networks. Next, we are going to be talking about the CIDR notation. Classless interdomain routing, commonly abbreviated as CIDR notation, is a compact representation of an IP address and subnet mask using a slash followed by the number of bits in the subnet mask. An example of the CIDR notation is 192.168.1.0/24. Next, we are going to be talking about calculating subnets. The steps for calculating subnets are: firstly, you need to decide how many subnets are needed. Secondly, you need to determine the subnet mask based on the required number of subnets. Thirdly, you need to allocate addresses to each subnet. And lastly, you need to ensure that you reserve the network and broadcast addresses. So we are going to be looking at an example of subnetting. If you have the IP address 192.168.1.0/24 and you need to create 4 subnets, you will need at least 2 bits for the subnetting. So your new subnet mask will be a /26 subnet mask. Each subnet will have 64 addresses. And in order for you to get those 64 addresses, you are going to use the formula 2^6, where the 6 represents the number of 0 bits in the host portion of your new subnet mask. The subnet will then have 62 usable IP addresses, that is after subtracting 2 IP addresses for the network and broadcast IDs. Understanding IP addressing and subnetting is crucial for network administrators, as it forms the backbone of how devices communicate over a network. It is also essential for network security, troubleshooting, and optimizing network performance. Thanks for tuning in to our Computer Networking Podcast. Stay connected for more tech insights and updates. Don't forget to like, comment, subscribe, and share. Until next time, keep your networks strong. Peace.